Alright, this is 10-3 regular polygons. If you remember from our vocab, from our polygon unit, a regular polygon is one that has all equal sides and all equal angles. Okay, this is our area chapter, so now we're going to be discussing the area of these things. The formula for the regular polygon looks like this. Notice there's a big A and a small a. Those are two different things. I have had kids in the past label this as a big A and it gets really confusing. So make sure you put the small a here, or the big A here and the small a there. Okay. The small a stands for, this is pronounced apothegm or apothegm. I have heard it pronounced both ways by tons of mathematicians that I respect. So I'm not sure there's a correct way to pronounce it. I've heard it both ways, apothegm or apothegm. Most of my students like apothegm because it sounds like a possum. I don't know why. The next word you'll recognize, perimeter. Okay. Another thing you'll need, another word you'll need is radius. And I can already tell what you're thinking. This isn't a section about circles. Why are we talking about radius? Well, a radius on a circle is the distance from the center to the edge of the circle. A radius in a regular polygon is from the center to a vertex. Okay, so not that this is extremely important, but vocab is extremely important. So you need to make sure you understand when I say radius, what distance am I talking about when I say radius. Okay. I usually do this lesson with nice pretty little stencils. I don't have those with me tonight, so I'm going to have to freehand this stuff. So I hope my artistic skills are to your pleasing. Alright, that is supposed to be a regular hexagon. I know it's not extremely pretty, but this length would be called a radius. Okay. So from the center to a vertex is called the radius. Okay. What is this apothegm thing? Well, the apothegm is from the center perpendicular to one of the sides. Okay. Coincidentally, if this is a regular polygon, this happens to be a midpoint. Okay. The triangle that's formed between a radius and an apothegm happens to be a right triangle, and it is going to be an extremely important right triangle, because since you know already that you need the apothegm for the area formula, hopefully you can guess by now that we're going to be reviewing a lot of right triangle stuff in the next couple of sections in this chapter. Okay, because you're going to have to be able to find this length if it's not given to you. Okay, this angle right here is going to be very important. Okay, that angle is always going to be 360 divided by twice the number of sides. Again, this is going to be very important in this chapter. Okay, let's talk about where this formula came from. How come it's 360 divided by twice the number of sides? Well, if I draw in every single radius and every single apothegm, how many total lines did I draw? Well, in this case, since it's a hexagon and there's 6 sides, I just drew 12 lines, 6 radii and 6 apothegms. So I divided the hexagon into 12 equal triangles. So to find the angle between two of these lines, I just divide 360 by 12. Write this on your hand if your parents allow you to write on your hand. I know some of you said your parents don't allow you to write on your hand. Put it on a piece of paper. Put it on the front of your notebook. I don't care where you put it, but you need to read that every single day. Okay? Alright. Your first example. Now, remember I've said in the past, do not follow these examples blindly. In this example, this is an equilateral triangle, and I am giving you a radius. Some of you are going to get to the homework and see a triangle, and you're going to try to follow this example step for step. Except the example in your book might give you an apothem, or it might give you the side of the triangle. Take every single example for what it is. Every single problem in geometry is different, which is why geometry is harder than algebra. Okay? You have to look at what information you're given, and you have to determine what information you need. Every single example will be different. Okay? So don't follow these examples completely blindly. That's the biggest problem I have every year in these units. Okay? So, I'm going to redraw this over here, just so, remember the idea behind Cornell Notes is that you can cover this up with a piece of paper and redo the problems on your own. Let's look at what we have here. We have a radius. It's 10. I'm going to draw in the apothem. That is my first step. If it's not already drawn for you on every single one of these problems, you're going to have to draw the apothem. Okay? Because, again, that apothem will give you a right triangle. I need both of the sides of this triangle. I need this side of the triangle because it's the apothem. I need this side of the triangle because I'm going to use it to end up finding the perimeter of the shape. Okay? I can't find either one of those sides until I find this angle right here, which is step 2 of every single one of your problems. Okay? So step 2, find the theta. In this case, it's 360 divided by 2 times the number of sides, which is 6. So 360 divided by 6 is 60. So I have a 60-degree angle. Okay. Step 3, find the sides of your triangle. Now I'm going to go ahead and tell you, in this section, in 10-3, every single one of your triangles is going to be a special right triangle. I'm going to work every single one of the problems as a special right triangle formula problem. If you want to use trig, you can, but that's actually the next section. Tomorrow's lesson will be all about using trig. So if you want to use trig today, you can, but you're on your own. We need to review our special right triangles. I'm going to be doing everything with special right triangles. Okay? In this problem, if the theta is my 60, that makes y my larger side and x my small side. If you remember, x is the short side because it is across from the 30-degree angle. 10 is my hypotenuse because it's across from the 90-degree angle. If you remember in the formula, you can go back and look at it, but in the formula, from the hypotenuse to the short side is just division by 2. So x equals 10 divided by 2, which equals 5. Y is the long side. And again, if you go back and look at those notes, the long side is just the short side times square root 3. So y equals 5 times the square root of 3. Okay. Now, how do we get from here to the perimeter? This is why. To get this length, I have to double it. Then I have to do it again. So how many Y's does it take to get the perimeter? 1, 2, 3, 4, 5, 6. It will always be twice the number of sides. So if you have this bottom part of the triangle, it's always going to be the bottom part of the triangle times twice the number of sides. So 6 times 5 is 30 square root 3. Okay. Okay, in this case you have a hexagon. This time I'm giving you a side length. So in the last example I gave you a radius. In this example I'm giving you a side length. Okay, again I'm going to redraw the picture so that you can cover it up and try to actually study, for those of you who actually do that. I know it's a lost art these days. Okay, what was step 1? If you look back at the previous example, step 1 was draw the apothem. So here's my center, there's my apothem. Doesn't hurt to draw the radius too. Remember, we're trying to get this triangle right here, right? This triangle right here is the important part. Now, which side of the triangle do I know? I know this part, because if this whole length is 22, is this part 22? No. This is a midpoint, remember? So this is 11. Okay, remember step 2 was to find theta, right? In this case, theta equals 360 divided by, there's 6 sides, so I'm going to divide by 12. Okay. 6 divided by 12 is 30. So in this case, my angle is 30. That makes 11 the short side. And 11 is the short side. And I need the other 2 sides of my triangle. Okay? Actually, I don't really need the radius. You never need the radius. You can find it if you want to, but you don't have to have it. This is my short side because it's across from the 30. Here's my right angle. That makes this my long side. So x is equal to 11 square root 3. Okay. Alright, last thing I need is perimeter. I have my apothem, I need my perimeter. Again, if you have the bottom side of the triangle, it's always multiplied by 2 times n. So perimeter is going to be 11 times 12. Which is 132. So this is my apothem. And this is my perimeter. So I'm plugging into the formula. Apparently my husband cleaned. My calculator isn't over here anymore. I have to use the calculator on my phone. Because this is going to be a big number. Okay, so 132 times 11 divided by 2 is 726 square root 3. And now that I just did that, I'm wondering if I forgot to multiply by 1/2 on the last example. Let me go look. Yeah, I never finished this problem, did I? Here's my apothem. Here's my perimeter. I never finished this problem. Sorry about that. That's what happens when you have a really long day. Alright, so plugging in, we have 1/2. The apothem is 30 square root 3. And the perimeter, oh wait, that was the perimeter. And apothem, hold on, let me do that. Let me fix that. 1/2. This was the apothem, which is 5. And the perimeter was 30 square root 3. And 30 times 5 divided by 2 is 75 square root 3. Okay. Last example. Alright, so I'm trying to give you all 3 possibilities. The first example gave you the radius. The second example gave you a side length. This example is going to give you an apothem. Now some of you are going to say this example is pretty ridiculous because if this is a square and this length is 3, then that means the total length of this is 6, so you could just do 6 times 6. So yes, obviously there is an easier way to do this problem, but for the purposes of demonstration, let's just go with it, okay? Let's try to follow the steps I've given you again. Okay, step 1 is to draw the triangle, right? We have this is 3, and we're going to draw that triangle in. Okay, so here's our triangle. This is the all-important triangle. Okay, step 2, find the angle. There's 4 sides, so we're going to divide by 8, which equals 45. If this is 45, then that makes this 45, which means this is an isosceles triangle. That means x equals 3. Okay, so my apothem is 3, and my perimeter is 3 times, there's 4 sides, so 4 times 2 is 8. Okay. Which is 24. So the area equals 1/2 times 3 times 24, which is equal to 36. Again, the same thing you would get if you did 6 times 6. But again, if you follow the 3 steps I've given you for every single problem, no matter what you're given, it'll work. Okay, so make sure you have your notes. Look over them more than once before we start this assignment, okay?